right, so before we were so rudely interrupted by the bell for our break, we just started talking about formal charge. This gives us, this is a way that, I don't know who came up with it, some guy, some person, I don't know if it was a guy or a girl, I don't know. Okay? They came up with a way to get a more accurate measure of the charge on each element, each atom within a compound. So, this is a formula that I would program into your fancy calculator because it's not on the AP equation sheet, but it's one you're going to need to know. To calculate formal charge, you simply go total number of valence electrons minus 1/2 bonding electrons minus total lone pair electrons. And it's total, not pair. Okay? On this one. Compounds try to always minimize their formal charge. So 0 and everything's the best. Okay? So we're gonna rearrange and share electrons differently based upon formal charge, trying to get everything at a formal charge of 0, the minimum amount. We don't want to be -1, -2, -3, or +1, +2, +3. We want everything to be close to 0 as possible. So when I calculate the formal charge on H2SO4, you have a sulfur, you have these two oxygens that are the same, these two oxygens that are the same, and then the hydrogens. Okay? We'll start with hydrogen first because it's super simple. How many valence electrons total does hydrogen have? Each hydrogen has how many valence electrons? 1. Minus. You got one bond here. How many? This one line represents how many electrons?
2.
2. So I'm going to go 1/2 of 2. Minus how many lone pair electrons are around the hydrogen?
0.
0. So that's going to equal 0.
Nice.
Okay? That one's easy. So both the hydrogens are going to be the exact same thing, so you don't have to do it twice. If you want, you can say out here the 2 hydrogens are both going to do that. Okay? Now, I'm going to label these as oxygen 1s and these as oxygen 2s, just because they're different oxygens. Okay, just so you know which ones I'm calculating. So I'm going to say oxygen 1, and we have 2 of those. So how many valence electrons does oxygen have?
6.
6. How many electrons are involved? How many bonding pairs do I have?
2.
2 pairs. So I have 4 electrons, right? So it's going to be 1/2 of 4. Minus, how many lone pair are around? 4. There's 2 pair, but it's 4 electrons, so you count total number. So minus 4. So it's going to be 6 minus 2 minus 4. What does that come out to? 0 again. So far, we're doing pretty good. But now we go to oxygen 2. We got 2 of those. We're going to go 6 minus, this time how many electrons are involved in bonding? Only 2, right? So it's minus 1/2 of 2 minus the 6 valence electrons.
Dang.
So now it's
-1.
-1. Okay, so the formal charge on this one is -1, and the formal charge on this one is -1.
What does that mean?
Well, let's just do the last one, sulfur. See if we can get it better. We have 1 sulfur. We have 6 minus, how many electrons are involved in bonding? How many bonding pairs are there? Bonding electrons.
8.
8 electrons, so it's 1/2 of 8 is 4. Minus 0. That's going to be plus 2. That's not minimized. When you have negatives and you have positives, the negatives share with the positives to minimize the formal charge. So the reality is that we're going to take 1 pair of electrons there and 1 pair of electrons there and make a double bond. Now that's way more complicated. Trying to explain how that happens I don't have a clue as far as the bonding and all this different mechanisms. But formal charge says that this is a more stable, more dominant structure than just with single bonds there. Because now look at what the oxygen's going to be. So now with the new structure, okay, we have 6 valence electrons minus 1/2 of how many? 4 minus 4 is going to equal 0. And the sulfur now, 6 minus 1/2 of how many?
8.
Not 8.
12.
12. 2, 4, 6, 8, 10, 12. Minus 0 is equal to 0. So we've minimized the formal charge. Notice what we did. We took from the negative and just made a double bond with the positive. Every bond that you form like that changes it by 1. So oxygen formed 1 bond, so it went from -1 to 0. Sulfur did that twice, so it went from +2 to 0. You seeing that? So you just keep sharing until you can. Now if it's an ion like ClO3 minus, the formal charge has to add up to -1 still. Okay, you're not going to be able to get them all to 0. All right. Let me just show you one other one, and then I'm going to let you loose.
So do you have to do that every time you draw loose?
Okay, good question. Great question. I'll face you when I answer. Do you have to do that every time you do the Lewis dot structure? The answer is no. Anytime you do the Lewis dot structure on my test or the AP test, you do it in terms of the octet rule, which is what you just did on that worksheet.
Yay.
If the question specifically asked or mentions minimizing formal charge or what's the formal charge is mentioned in the question, then you have to do it in terms of formal charge. Okay? So on the AP test, on my test, you assume you follow the octet rule. But if the question asks about formal charge, you have to do it this way. So, there was a question on the AP test not too long ago for HCN. Okay? When we do H, is it HCN? Maybe it's SCN. SCN minus. Thiocyanate ion. When we count, we have 6 plus 4 plus 5 plus 1, so we get 15, we get 16 electrons. Okay? Carbon's going to be in the center because it's got the fewest number of valence electrons, so it's SCN. 2, 4, 6, 8, 10, 12, 14, 16. So, what's the deal? How do we fix this? You can do 2 double bonds, right? Or what else could we have done?
Triple bond.
We could have gone sulfur, carbon, triple bonded to nitrogen, because nitrogen can form triple bonds. So which one is going to be the more dominant? Which one is going to be the one that the molecule is going to want to go into? Well, this is where we do the formal charge. So in this one, sulfur, 6 minus 1/2 of 4 minus 4, sulfur equals 0. That's good. Carbon, 4 minus 1/2 of 8 minus 0 is equal to 0. Nitrogen, 5 minus 1/2 of 4 minus 4 is equal to the minus 1.
It's unfortunate.
Okay, well, it's minus the ion. This is an SCN minus ion anyway. So it has to add up to that. So that's pretty good. Okay, let's look at this one. This sulfur, 6 minus 1/2 of 2 minus 6 is gonna equal
Negative.
-1. Carbon is going to be 4 minus 1/2 of 8 minus 0 is equal to 0. And nitrogen is going to be 5 minus 1/2 of 6 minus 2 is gonna equal 0. Okay, now they both seem to be minimized. So how do we pick? You have the -1 on sulfur, the -1 on nitrogen. Pardon me, -1 on nitrogen, -1 on sulfur. Which one do you think is gonna be more dominant or more favored?
Sulfur. Nitrogen is more polar, so I think
Okay, more polar. What makes it more polar?
it's higher electronegativity.
The greater the electronegativity. When you have a tie kind of like this, the negative charge is going to go on the more electronegative element. Okay? Which is going to make this one the more predominant form. The -1 on the more electronegative element. Okay? So, between these two, we put it on this one because nitrogen's more electronegative than sulfur. So however you want to write that down in your notes, but that's something, this was an AP question 3 or 4 years ago. Which structure would be better based on formal charge? Okay? So, it's gonna be tedious, but I want you to go through on the front side and calculate the formal charge, and then if you need to, redo the structure to minimize formal charge. You can do it, you can either do it on that one or do it on a separate sheet where, you know, you redraw the structure or, you know, if there's space to do it on that sheet. But we're also gonna do bond angles and we're also going to do, shapes on that same sheet. Okay, how do I?